Hi, in this video, we will discuss how we can leverage large language models to extract legal entities from legal documents. Either it may be a court order or a contract or any kind of legal document. So, we try to leverage artificial intelligence or large language models to extract key entities from the document. Why we need this actually? We can find what we need instantly from a big document which contains more than 100 to 200 pages. Searching through these documents manually is exhausting and it is time consuming. So if you have a data set which you can just write a query and search it and get the citation and all the documents, it will be very easy. So that we can able to achieve using large language models. So I will show you a demo like how we are going to achieve that one. So first thing like why we need, so we already discussed like we need especially if there are thousands of documents and we need to extract entities or any kind of case sensitive information from the documents, it is manually time consuming. Apart from that, there may be some cases where human error may arise, especially during high stake merger and acquisition due diligence or regulatory compliance. Missing a single clause can be a catastrophic. So automatic extraction ensures nothing important slips through the cracks. So that's one thing. And the new associates who joined in a law firm can spend years rebuilding knowledge and exit. So give them instant access to the firm's collective database, then they can quickly or reduce their time to get into the work what actually expected to do. So instead of manually recollecting all those things, they can just ask the LLM or database to give whatever information they require. And scale without proportional head count. So that's a beauty like here. So we can feed any number of documents and get the required extracted entities or any kind of like a structured in the form of structured output and stored in database, so that it can be further used in a downstream application or any other kind of application where if you have a structured document, based upon that we can build a application which even AI agent can use it. Apart from that, using AI but definitely improves the firm's competitive advantage over who are not using it. It improves the quality of work and it will greatly improve how actually the lawyers can able to get the information required at the right time. And also if there is an urgent requirement and they want to get specific details from that particular document, it can be satisfied like just getting the relevant information from the database itself. So I will show you a total end-to-end pipeline, how we are going to feed the document and get the entities and then finally store it in a database and actually use a SQL query to fetch the document or fetch the required information. I will go through a step-by-step process how we can do that. We know that especially the legal work is fundamentally about information, finding it, analyzing it, applying it. So if we have the right information at the right time, then definitely it will be a like it will improve the quality of value delivered by that particular lawyer or a firm. So we will see like how we are going to structure this. So this is the system what I propose, like how we are going to showcase the demo as well. First we have input layer. So in this input layer we have legal documents. It may be either in the form of PDF or a document or text or Parquet. So Parquet is a little bit technical format where it is a columnar format, especially used in data engineering or data pipeline side, where we convert all the text documents or PDF documents into Parquet, and then it will be very easy to process to downstream, so that if there are a huge amount of documents, maybe thousands of documents, we can condense them in the form of Parquet format and put it in and store it in a very efficient way. So that's why I included particularly this Parquet format. Usually we process we have legal documents in the form of PDF or document or on a text, but there is a way like we can convert these documents in the form of Parquet, and we can store it in an efficient way in a database, such that the further processing will be very easy and quicker. So here I want to take a leverage of this particular Hugging Face dataset. I will show you like what it actually contains, and what are the things we are going to need in that particular dataset. So there are different formats available. On that we are going to concentrate only on this particular format which I mentioned here. This I will explain in detail, like how we are going to extract and what are things we are going to do. And then we have a pre-processing layer where we are going to extract the text and then clean it and make it further available for the downstream processing in a clean format, such that there will be a layer by layer approach where we can extract whatever entities we require and store it in a database. So then after cleaning and text extraction, we process that via LLM processing layer. Here I'm using a Gemini latest Flash latest model. So here it is a combination of prompt engineering as well as how we are going to extract those data. So these are the key points I want to highlight here, like the prompt engineering is a process where we instruct the large language model how it has to give the output to us, and also we are going to give the context, like what are the things we are providing to it, and what we are going to expect from this particular context, and how it has to process and give the answer. So like a large language model is it's a system where the way and how you want the answer, based upon that one it will give you a very good or proper output. So we need to design the prompt in such a way that the large language model has to understand it, and then it will get the context, and based upon that it will give you the correct answer for the query. So we will see how actually we attain this while showcasing the demo. And then we have response processing. So we got everything in the JSON format, and then that one will parse it using Python list, and then get all those data whatever we require. And finally we store it in the database. So here for this demo I am using SQLite with FTS5 full text search option, because the legal document contains all of them are text only. So we need to, like for example, we need to have a facility in such a way that if there is a query searching for a term or searching for an entity or searching for any kind of text, then it has to work. So for that only I purposefully add this FTS5 full text search facility here, so that if you type on any text, it will hit the database and get the retrieved data. So why we are using this means, like this can be further utilized properly in retrieval augmented generation step. So then we have the query and output layer. So this we can either search by entity or a text or based upon the requirement of the search query, it will fetch the data from the database. So this everything was stored in a database, in a permanent database. So it is very easy for the business to have the database, and then it can adds upon, like whatever they are getting new documents, and any document is processed and then added to this database. So it will be like an asset, a database asset, such that they can go back to any time period and fetch their details, like whatever they want to see, or they want to analyze. So here if you see, I just classified 9 entities here. So the first one is person. It may be appellants, respondents, witness, or counsel. And the second is organization. So what are the organization? Like either it may be companies, institution, government bodies, etc. And then location. So city, provinces, jurisdictions, regions. And then legislation, like statuses, acts, sections, and regulations. And then case law, like these are the examples. And then legal topic, judge, court, and law firm. So here the performance metrics, like whatever I tested, it was almost the accuracy was 95%. So we can further improve this, like depending upon the prompt. And then this is like, it is a process where it continuously improves, and then we can able to achieve accuracy of about 99% as well. But we need some fine tuning, and then prompting techniques that can be added. So here the technology stack what I used was Gemini latest model, Gemini Flash latest model. Why I went to this model is that mainly because of the cost economics, like it is comparatively cheaper to the other model, and then programming Python, and then database SQLite with FTS5 search capabilities, and these are the libraries I used. And I want to thank A2AJ Canada, this particular Hugging Face, for making Hugging Face dataset. So I will show you like what actually it is and how it looks. And these are the entities classification flow we have, like it will extract person, organization, location, legislation, case law, general topic, a legal topic, judge, court, and law firms, etc. Colab demo. Here I will show step-by-step process how we are going to extract and save it into the SQL database, SQLite database. Let us start. So for this you don't need any fancy GPUs. This all runs on Colab free tier CPUs. That's enough. Since we are going to process everything on like in a Gemini Flash model. Okay, so we are importing previously we installed all those libraries what we require, and then we are importing the libraries here. So here I'm getting the key. So there is an option in Colab where we can store it secretly, the API key, and then retrieve it into the notebook. So I'm just printing out what are the models available, especially for this use case. We are going to use Gemini Flash, which is comparatively cheaper. So I'm giving a Gemini Flash latest so that it will take the latest model. It will be a Gemini 2.5 latest. So here this is the actual data set. Like now if I can show you, so they have the GitHub repo as well. So this is the data set I mentioned previously. So they have a GitHub repo. You can see here access to algorithmic justice A2AJ. So thanks for them. So they maintain a really very good data set, like where we can get the data for our use case. So I'm using this particular Canadian case law data set for our demo. So you can go through it and see like what are all things are available there. So here there are different code decisions we have. So in that I'm fetching only Ontario Court of Appeal this particular data set, and at that time it was almost 16,951 cases available at that time. So that is that data set, about data set, and then I'm just fetching in such a way that we are seeing like what are the one particular data set here, like Ontario Court of Appeal, because this entire thing will be very huge. We are going to analyze only the subset. In that subset also we are going to fetch only few records, since this is only a demo, but this can be extended to any number of documents as well. So I'm getting the data set and with the prefixing and all those stuff, so that it will be very easy for the further processing. Like if you want, you can change to any legal entity, like for example for any court like tax court or court martial appeal court, something like that. So it was done. So you can see it is almost 17,177 cases. So they recently updated, it seems. So now after that we are going to do the now the actual entity extraction function begins. So here we are going to have only 30,000 length of text, because there is a limit for the LLM to process. It is called token limit. For to considering that one, I made it as 30,000 as the maximum text length. If the text is more than that, then we need to truncate it. So but in real use case, we can chunk the document and then process it. So here this is the prompt or the instructions we are giving to the large language model. So how it has to extract and how it has to give the required answer or required data from the given text. So the instructions say extract all named entities like person, organization, location, legislation, case law, legal topic, judge, court, law firm, with detailed descriptions from the following Canadian legal case text. Format the output as JSON array for entities. So this is how we are going to like expect the answer or the extracted text from the large language model. So this is example output format. So this we call it as a few short prompt. So we give the examples as well. We give the detailed instruction and we also give the examples as well, such that the large language model understands it correctly and then gives the output. So here we can see the entity types, like what are the entity types and how it looks like if it is a person, parties involved, organization, what are the company's location, legislation, case law, legal topic, judge, court, law firm, etc. So here and we are giving the text. So this is one of the important concept in large language model, what we call it as prompt engineering. So if we can able to fine tune this prompt based upon our needs, we can further enhance this such that we can get more and more accurate answer or required data from the given text extracted. So that's one thing. And creating the prompt and then passing it to the LLM and getting the response. Okay, so this is just cleaning up the JSON as I previously discussed, and also we are adding the citation for all the given entities, so that the citation will be useful as a metadata to extract or to refer back. So let us run this one. So we are going to use that particular function or entity extraction function which we described earlier. So that we are going to use, and we are going to take only three records or three use test cases here from that particular Hugging Face document. If I can show you here, there is a Hugging Face link. Yeah, this is the Hugging Face link. If you can see this, we are going to take only three from that particular data set and then process. So this is a very huge, like if I click here, this is one. So if you can see here, yeah, this is the one name. Okay, so see this. So it is so big. Let me scroll to the right. Yeah. So the actual text, we have it in unofficial text underscore en. So these are the different columns we have with the metadata. So now here this is the actual legal document in the form of text file. So from this only we are going to extract all the entities what we require. If you can see here we already have this, I think. Yeah, so here dataset citation extraction URL and then unofficial text en. So this is the one. So you see this is actually a big document, but it was showing like this in Colab notebook, same way what we have seen here, this one. So now we are going to use this particular column data for each record and then process it, give it to the LLM and get the required entities extracted from that one. Okay, so here yeah, so here we are going to take only three records or three cases, legal cases, and then from there only we are going to process, because we don't want to overload the system here. This is just a demo. So I will run this. So what it takes, it will take the three case files and then process it. You can see case 1 2017 ONC 708. So it's processing that particular file, and then once it processes it extracts the entities. See, processing case 2 2017. Okay, so we will see what this one actually means here. So I think we can, if we can. So this is the actual PDF document for that particular case. Okay, so it is already done. So it done for 27 ONCA 708, 27 ONCA 71, 27 ONCA 710. So from this particular document it extracted 19 entities. The second document it extracted 23 entities, and the third document it extracted 24 entities. So it depends upon the cases as well. So it also, like we have also the entity breakdown. So person, organization, judge, case law, court, legislation, location, and legal topic as well. You can see here a sample output, like we have entity name, entity type, description, and citation as well. So entity name, this is the name, and entity type is case law. So it correctly recognizes like what is entity type and what is that particular entity name for that one. And description also, it gives us our description as well. So now we have the data set in the form of we have a structured data set in the form of data frame. So now this one we are going to store it into the database. So here I'm using SQLite database, but in a real production use case we can use any SQL database and then load it into that, and that will be an asset for that particular business, where they can go on adding those records, and then they can have the searching capability, and also they can build a agent on top of that, such that it will behave as a chatbot. Like we can ask questions and then it will give the relevant answers. So that is a key point here. So first we have a proper data or database, then we can do any on top of that we can build any system which can be easily accessible by the end user. So now I'm going to run this. I will explain. So I'm creating a database called legal entities DB. Here I'm creating a table named entities, where it has citation, entity name, entity type, and description, and create a timestamp as well. This is all for indexes, which is for fast searching. So we have indexes, easy for the system to search based upon the index as an added criteria. So these are all technical side, where I created some triggers as well in order to upload any new data or update such kind of things. This is all like a simple SQLite, but same thing we can apply for a production database as well. So now loading the data into the database. We have the data ready, and then database ready. Now we already loaded a database with the records. So you can see the legal entities database has been created here. So this is the database we are going to use to query. So once the processing is done, and then so what we did, we upload the documents, and then from the document we extract the text, clean it, and then send the text to the LLM, and then LLM process those text and then give back the result in the form of entities and all the details what we require for further loading into the database. And we created the database, and then finally we load into the database as well. So now this is a simple search function based on entities I created. So it directly queries the database and then gives the required answers. So search functions are defined here. So now we will write a query, search for criminal code references. Okay, so let us run this one. Okay, so results. Okay, we are going to search term is criminal code. It found a criminal code here. Yeah, these are the criminal code, and also give the entity type as registration, description, all those stuff. So let us search for any other thing like person. Will be person. See, it give person. So all the details like let us check whether this person is really available in this particular document. See, it clearly extracted the what are the record. So it consider representing the appellants. Okay, see. So this is what actually we require. Like we have everything. Just we need to query the database, and it will fetch everything, whatever required for that particular analysis, case analysis. We can also, like, what are the entities we already discussed here. Okay, so we have person, we have organization. Okay, let us type organization. Do we have anything in those first three records? Yeah. Okay, so we specifically mentioned as organization, that's why it should pick up. So we have this one, Ustasi Holdings Inc. Okay, let us try this one as well. Where is the search? Okay. Yeah, we have this. So we can type anything and we can get the answer immediately. So once we have this data in our database, then no need to depend upon any large language model, because everything it is fetching from the database itself. So this is one time processing and storing it into the database. So once it is stored, then it's all like just a query, like we need to fire it up and then it will get the answers. So now let us find all the judges mentioned here. So you can see these are the judges mentioned. Let us try this. Yeah, so it correctly gets everything. What else? So what to sound tune? Okay. So we get the judge, entity type judge, person we already checked, all those things. Okay, so here I just want to show what are the data we have in the database. Um, we have the citation, entity name, entity type, and the short description about it, and then the timestamp as well. This is when we get it in our system. Yeah, this is our system time. Yeah, so this is for like I want to show you like what are the data available in our system. So here we have the entire thing, like ID, citation, entity name, entity type, description, and created at the timestamp. So we can see that it clearly gives the entity name and entity type, what is entity type, and we also checked like what are the things available there. So this is from the data itself, database itself, and then if we can see the statistics. So what are the things we have, what are the entity type, how many entity types we have, like the count for person, organization, judge, case law, code, legislation, legal topic, and all. And top 10 most common entities are these are the things: entity name, entity type. Here we processed only three records or three case files. So this can be extended for any number of case files. So if we can see in this particular data set, we have almost or also we do have this one here, I think almost 17,000 records or 17,000 cases we have. So for processing this, it doesn't require much time, but definitely we are not going to use Colab. So in the production scale, we can define the we can design the system in such a way that it can handle a huge amount of documents. So this is a short demo I want to show you, like how we can leverage large language model, especially in legal domain, to process huge amount of documents. So hopefully I think you find some value in this, and then yeah, so this is what I want to show. There are about 17,177 cases, especially from this particular Ontario. I think this is Ontario Court of Appeal subset data. Yeah, so this is a short demo that I want to show you, like how we can leverage large language model in processing legal documents. Hopefully you can find some value from this. Thank you.